Hello, and welcome to today's lesson, Lesson 5, our last lesson in Logical Reasoning 2. And today we're going to be looking at the side lengths of a triangle. So we're going to be looking at a few situations here. We're going to be able to determine whether three given side lengths can make a triangle. We're going to determine the possible range of values for the third side given two other sides of the triangle, and then also look at giving the sides of the triangle, list the order of the angles, given the angles of the triangle, list the order of sides from smallest to largest, largest to smallest. So in our first situation here, we're looking at what we call the triangle inequality conjecture. Okay, the sum of the lengths of any two sides of a triangle has to be greater than, okay, it can't be equal to, but it has to be greater than the length of the third side. Okay, and let's see why this works, why this is important. So if we look at example 1, we're looking at this three-angle pair, our three-length pair here. We've got a 2 centimeter side, 4 centimeter side, and 5 centimeter side. And I have those pieces here. And we want to understand, can these make a triangle? Now, based on the rule, 2 plus 4 is 6. 6 is bigger than 5. 2 plus 5 is 7. 7 is bigger than 4. And 5 plus 4 is 9. 9 is bigger than 2. So based on the conjecture, we know this works. Okay, but let's work with the pieces. Okay, so we've got our three side lengths here, and all I'm going to do is just start rotating them and see, can we build a triangle out of these pieces? Okay, so now we can see here, okay, we're not quite touching yet. Got to make sure that we're bringing these pieces down a little bit more. Okay, all we're doing here is just kind of changing the angle of the connections. Okay, we're almost there, so we just got to go a little bit more. Let's see if I can get the right side length here. I need this guy. Let's pull that. There we go. There's the guy I need right there. To bring him down just a little bit more, so then we can connect the pieces, and we made a triangle. Okay, now our next three pieces that we have here, we've got a 5, and a 7. Okay, so 5 plus 5 is 10. 10 is greater than 7. 5 plus 7 is 12, greater than 5. And 5 plus 7 is 12, greater than 5. Okay, so once again, based on the conjecture, we should be able to build a triangle here. And then all we're looking at is taking the pieces, and this one would actually be an isosceles triangle if we can go through and build this. And all we're doing is altering the angle measurements of these pieces so we can put together, okay, we're almost there. We just got to bring up this other angle here just a second. And we've got it. So we've got those two pieces here. We bring in our third piece, okay, and, you know, it's a roughly built triangle, but we have built the triangle with that piece. Okay, so both of these first two work. Now, when we look at this third situation, we've got a 6, a 3, and a 2. Okay, we can look at it right now. 3 plus 2 is 5, and 5 is not greater than 6. So if I look at these three pieces, I'm probably going to have trouble building a triangle, because what's going to happen here is as I rotate these two small pieces to try to build on to this long piece, okay, there's no angle that I can create that's small enough. Okay, so here I'm going to have to make the smallest angle possible with these two other sides. Okay, and there's no angle I can make small enough to make these two pieces connect. Okay, so that's why the triangle inequality conjecture works. It works based on, can you make an angle bigger or smaller so that those two endpoints can connect? Okay, now, when we're looking at a situation, we might want to find out what is the range of the possible values of the third side. So what can happen is the 4 and the 7 can be the two smallest sides, and then there could be some third side x, which would have to be the largest side. Because remember, we're looking for a range. So we're looking for the two extremes here. So either x is the largest of the three, so then we know that 4 plus 7 would have to add together to be greater than x. So now we know that x would have to be less than 11 centimeters. Now, on the other extreme, x could be the smallest of the three. So we could have an x, we could have a 4, and now that makes 7 the biggest of the three sides. So then we know that x plus 4 has to be greater than 7. We subtract 4 from both sides, and we find out that x would have to be greater than 3. So now we have the range of values. We don't know what the length of the third side is, but what we do know is that x would have to be greater than 3, and it would have to be less than 11 in order to have a side length that could work with the other two pieces we already know, the 4 and the 7, to make a triangle and have those sides connect when we shrink the angles down. Okay, now, the next thing that we're going to look at here is what's called the side angle inequality conjecture. So in any triangle, if one side is longer than another side, then the angle opposite the longer side is larger than the angle opposite of the shorter side. So we can see here that 94 is the biggest of the three angles. So then we know the side opposite, EF, is the largest of the three side lengths. Okay, so that's greater than anything. And then we move to the next smallest angle, and that gives us the next largest side. Okay, so we always go from large to small or small to large. We can go in either order. So this one is going from largest down to smallest side. Okay, but we could flip it around. And then our smallest angle of 32 is directly across from our smallest side, which is DE. Okay, we can do the same thing in the opposite order. Now we're given the three side lengths. Okay, and in this case, we want to do this in ascending order. So when we ascend, we want to go from small to large. Okay, so we want the smallest angle first. So what we have to identify is the smallest side length. And the smallest side length is across from the smallest angle. So angle A is less than any other angle in the picture. And then we go to the next side length. Across from that is our second smallest. Okay, angle C is less than, and then we get to our largest side length, which is across from our largest angle, which is angle B. So now this would be in ascending order. We've got a less than and a less than. Now, if we wanted to go in descending order, we would just flip this around, and B would be greater than C, which would be greater than A if we wanted to go in descending order. Okay, now, last example we're going to look at here, and then we're going to look at some of these big picture angle pictures that we've been giving you to see how we can break those down. I've got two triangles here. So when we have two triangles, the first thing that we have to understand and look at is which one is the big triangle and which one is the small triangle. So here is my big triangle. I can see the side lengths in that triangle are a lot larger than the side lengths in this triangle, which we'll call the small. So what we have to do in that situation, okay, we've got a couple missing angles here, so we have to fill in the pieces. I'm going to have to fill in the piece here, fill in the piece here, and fill in the piece here. Okay, so we have to fill in those angle measures first. So we can go to our calculator. Okay, we've got some information that we know. We know the two base angles, 38 and 33. So I'm going to subtract those from 180. Okay, to get 109 for that upper angle. Okay, we also know down here in the corner we can see the box, so we have a 90-degree angle. So we've got 90 minus 38 for that next piece. Okay, which is a 52. So we can fill in that angle measure. And then our last one, okay, we've got another triangle, 180 minus 89 minus 52. And we get a 39-degree angle there. Okay, so now, in this question, we want to list from descending order. So we want to go from large and the largest side all the way down to the smallest side in the picture. Okay, so what we have to be careful, okay, we're lucky here, 109 is the largest angle in the entire picture. Okay, but we have to identify and work off of the large triangle first. Okay, so the largest side is D. Okay, it's the biggest side of the largest triangle based on angle measures. Okay, and that is greater than the next largest side, which is E. Okay, because we went from the 109 across from that. The 38 across from that is E. Okay, which is larger than C. C is the shared side. Okay, it is the smallest side of the big triangle, but if we flip over, we can see that it's the largest side of the small triangle. And then we have to work through our other pieces. Okay, we're getting a little busy here, so I'm going to switch colors. Okay, we've got the 52 is the next largest side. Our next largest angle, which is across from B, the next largest side, and then finally 39, the smallest angle in the smaller of the two triangles, which is across from A, which is our largest piece. Okay, so this is descending order. D is the largest of the sides in the diagram, and A is the smallest. Okay, so that concludes our lesson for today, but the last thing I want to do is start to look at some of these triangle pictures where we're giving you a lot of information and you have to break things down. Okay, what we have to remember in these pictures is everything that we've taught you so far. Okay, we have parallel lines. Okay, so we have a set of parallel lines here. And parallel lines give us a lot of good information because I know that if this is G, I know that actually G and H are the same angle. Okay, alternate interior. So what we can do is we can start putting in tick marks to see what's the same. Okay, I've got a vertical pair up here, so those two are the same. Okay, H is the same. I've got a vertical pair down here. Okay, and then we have a similar situation over on this side, and we're just going to have to be careful here with tick marks. Okay, what I know is I know that D, okay, I'm going to go 2 tick marks there, and this angle are the same. Okay, D and C, alternate interior pair. I have a vertical angle pair here. And then we know that we've got linear pair angles. D and E, I'm going to go 3 tick marks for E. D and E add up to 180. Okay, I've got a vertical pair with E here. I have a alternate exterior pair with B. Okay, I have a corresponding pair down here. Okay, so we get a lot of information when we look at parallel lines. So that's one of the first things that you want to look at, is you want to look at parallel lines, understand what pieces are equal, understand what pieces are bigger than 90 and which ones are less than 90, and make sure that your answers match. And then the next piece that we have is triangles. And what we have to understand is we can work with a small triangle, like we have here, but we can also work with some larger triangles. Okay, I've got a larger triangle here. I've got a larger triangle here. Okay, so you always want to look at and see what triangle can I make, what parallel lines can I work with, and am I given any other important information? Okay, some of the important information that you're given in this diagram is this 90-degree angle. Okay, because if that's 90, that helps us with all of our angles down here as well. Okay, we're also given an isosceles triangle based on the 2 tick marks here. So if we're given isosceles triangles, we know that the base angles are equal to each other. Okay, so there's a lot of information given in this, and we want to put all the information in first. What do we know? What can we work with before we start moving on from there? Thank you, and have a great day.